part of 2.5. And what we're going to do is take some data and sort of make a line that represents the data. Because these points don't make a line, but we can sort of make a line that is close to representing the data. Okay? So when you have lots of dots on a graph, it's called a scatter diagram. Okay? So let's just look at an example. So here it talks about the tuition fees for a university and what is the cost in dollars. So if the year is 0, it says here represents 2005, 1 represents 2006, 2007, 8, 9, and 2010. Okay. And here's the actual data here. So it looks like 2005, it's 5,500, but it's just under 5,500. So it says find an equation that models the data. So we want to find an equation that represents this data. So we take 2 points on the graph. So I would choose the first one and the last one. My first point is use the real data here, not the approximate data from the graph. So I'm going to use this and this. But I can't use the year 2005. I have to say when x is 0 and when x here is 5, because 2010 represents x is 5. Okay, so this has to be 5. So the first thing we do is we just find the slope. So we're just going to go this, subtract this, subtract this, and then here's my slope. So it says approximately tuition goes up $423 a year. Now we have to find the y-intercept. Because I have lots of data, here I can find the y-intercept sometimes. So here it's when x is 0. So here's my y-intercept. It touches at 5,500, but exactly 5,492. So that's my y-intercept. So now I have my slope and my y-intercept, and I can just make the equation. However, that's not the interesting part. The interesting part of this is estimating and predicting what the future is. So we only have data up into 2010, but now you can say, how much do you think the tuition will be in 2012? So that's what this question says. Use the equation from part A to predict, that means like tell into the future, the cost of tuition and fees in the year 2012 when x equals 7. Because 2011 would be 6, 2012 would be 7. So I just put x equals 7 into the equation, and I can say, in 2012, the approximate or predicted tuition and fees would be 8,500. So let's do some examples. So here's another tuition question. So it says the average annual tuition and fees for a university are shown in the table. Okay, and it's also represented here in the graph. And it says x0 represents 1990. So that's 1990. So that would be 92, 94, 96, 98, and that would be year 2000. Okay, so it says find an equation that models the data. So the first thing I do is I find the slope. But I need 2 points. So let's take 2 points, the first and the last. 1990, but 1990 is represented by 0. So my first point is going to be 02035. Now, why do I put 0 here instead of y is 0 in the x spot? Because here, x is year, time, okay? So x is always going to be the year and the time. So that's my first point, and then I'm going to take my last point. Year 2000 is when x is 10. So when x is 10, the tuition is 3774. So those are my 2 points. So now I'm going to subtract the y's. and I'm going to subtract the x's. And if I put that in my calculator, it comes out to 173.9. So that means approximately every year, the tuition goes up $173. My Y-intercept here at 2,000. But is it exactly 2,000? No, 2035. So that's my slope, that's my Y-intercept. So my favorite equation is this. So I know my equation is MB. So there's my equation that represents this data. So we're pretending there's a line that goes through there. Now it says use the equation from part A to predict the cost of tuition fees in 2002. Okay, so year 2000 is when x equals 10. So 11 would be 2001. 12 would be 2002. So they're saying, what is the tuition when x equals 12, which is really the year 2002. So write my equation down. That's not my equation. And then just put 12 here. So y equals 173.9 times 12 plus 2035. And that's equal to 4,121.80. So in the year 2002, tuition is predicted to be $4,121. Okay. Let's look at another example. The table and graph show the percentage of women working in the United States from 1995 to 2000. So if we look at 1955, oops, that should say 1955. In 1955, only 35% of the women worked in a job outside of the home, but in year 2000, 60% of women worked outside of the home. So it says use these points to find an equation that models the data. So we just have to make an equation. So the first step is you need to find your slope. Well, they gave us the points, but we can't use the year. We have to use 0, 1, 2, 3, 4. So 1955 is 0. That goes up by 5, so this has to go up by 5. That goes up by 5, so that's 10, 15, 20, 25, 30, 35, 40, 45. So 1955 is 0. And 1995 is 40. So now there's our 2 points. Now I'm going to subtract the y's first, always on the top. And then on the bottom. So my slope, if you put that in your calculator, it's equal to 0.58. Okay, so now we need our y-intercept. It tells us right here. Which point do I choose, the x or the y? Well, this is 40. Well, it can't be 1955. It has to be the y value. Okay, so just underneath 40 is 35.7. So that's my y-intercept. Oops, I just put y. I should say y-intercept or b. It's the same thing. Now, what's your favorite equation? Y equals mx plus b. So I just put that information in. Y equals 0.58x plus 35.7. So there's my equation. So if we make a straight line, we just made a straight line that goes through those points that kind of represent this data. It's not perfect. It's kind of. So now it says use the equation from part A, this one, to predict, that means tell something about the future, the percent for the year 2000. Okay, the year 2000 is when x equals 45. So they're saying if x equals 45, what is the tuition? So let's write out y equals 0.58 x plus 35.7. Y equals 0.58. And instead of x, we're going to put 45 because that represents the year 2000. Now put that all in your calculator and you get 61.8%. So in the year 2000, almost 62% of the women were working outside of the home. Now remember, this is an equation or a line that it's not giving the exact data. It's not representing the data exactly. It's approximate. It's takriban, approximating. Because here's the real data. In the year 2000, 60% of the women worked outside of the home. And when we use our equation, it says 61.8. So this is a little bit too high, because reality is it was only 60, but it predicted to be almost 62. So it's not perfect, but it's close. Grib, it's very close. Okay, let's look at the last question. Okay, there's a small city and its population has been growing linearly in a straight line. In 2004, the population was 6,200. By 2009, there was 8,100 people in the small town or city. Assume this trend continues. So assume they just keep having babies at the same rate. Find an equation that models the data. Okay, well, I don't have a graph with lots of points. I just have 2 points. Okay, so if I just have 2 points, my time always goes on the x-axis. Just let me make this. I made it more focused. So the time always goes on the x-axis. So when I make a point, so in 2004, the population was 6,200, and in 2009, the population was 8,100. So I have 2 points, 2004, and then I have, oops, not 8 there, 2009. Okay, so now I have to find my slope first. I'll subtract the y's first on the top. And I'm going to subtract, just a minute. Okay, but we can't use the year. So what we have to do is go, okay, well, this is the first year that we have data. So let's call this when x equals 0. And how many more years later is that? That's 2005, 6, 7, 8, 9. So that's 5 years later. So if I add 5, x equals 5 for 2009. So really, I have the point 0, 6,200, and this is 5. Okay, so this changes to 0, and this changes to 5 years later. So then on the bottom, I go 5 minus 0, and then I have to use my calculator. 8100 minus 6200, on the bottom, 5 minus 0, 380. Okay, now I need to, because I don't have a y-intercept. I don't even have a graph. So what I'm going to do is I'm just going to choose a point. Which point looks nicer? The one with the 0 looks nicer. So let's just use this point. So I'm going to use the point, and I'm going to use m equals 380. And what's my favorite equation? This one. Okay, I can put that in. And that's x and that's y. So I can, that's y, that's 6,200 for y. M is 380, x is 0, plus b. 0 times 380, that's 0. So that says b equals 6,200. Okay, so now let's make my equation. What's my favorite equation? This one. I know B and I know M, so I can go Y equals 380 X plus 6,200. Whew, I have my equation that represents the data here. Now it says predict the population for 2013. Okay, so just wait. 2004 was when X equals 0. 5 years later, 2009 is when X equals 5. Now I have to get to 2013. So 10, 11, 12, 13. So that's 4 years later. So add 4, that would be 9. Okay, so when X equals 9, that's 2013. So now I say predict when the year is 9, which really represents 2013. So let's write down our equation and put 9 in for X. Now we have to use your calculator. 380 times 9 plus 6,200. So this means in year 2013, we predict there to be 9,620 people in the town. So that's the population. Okay, it's a prediction. It's not going to be exact. It's going to be approximate. Okay.